In this section, we're going to do a case study testing for a leap year. Let's start with a little bit of mathematics. I pulled this from Introductory Theoretical Math. This is an operation called divides. You're familiar with it. It's just rearranged in how it's explained. Often it is necessary to determine if one number divides another number. That means it divides it with no remainder. For example, 4 divides 20 because there's no remainder. 4 does not divide 21 because there is a remainder. In Java, we can use the modulus operator to determine divisibility. We would do modulus and then test for the value of 0. The way to read this third line is m divides n, and in Java that would be n mod m equals 0. So the concept of divisibility is easily translated to a programming statement. Let's discuss the characteristics of a leap year. If 4 divides a year, it may be a leap year. Usually it is, but not always. If the year is also divided by 100, then it is not a leap year. For example, the year 1900. 4 divides 1900. 100 also divides 1900. But here it says if 100 divides the year, it's not a leap year. Now, there's even an exception to that. If the year is divisible by 400, then it is a leap year. So again, for the year 1900, 4 divides 1900, suggesting it may be a leap year. 100 divides 1900, saying it cannot be. 4 divides 2000, maybe it is a leap year. 100 divides 2000, it cannot be a leap year. Well, let's do the third test though. 400 divides 2000, therefore it is a leap year. We kind of leap back and forth between whether it is, isn't, and is. The complication of this makes the coding a bit tricky. We have to take all 3 cases into account to determine if a year is indeed a leap year. This is more complicated than we've done. Java provides the and the or logical operators along with the not operator to help us. Let's assume a year y, whatever that year is. We're testing its property of being a leap year. We start with 4 dividing y. If that is true, we go on to test 100 divides y, and we want that to be false. If it is not false, then we do not have a leap year. If it is false, we do have a leap year. Even if that is false, the year still could be a leap year. We're also going to test to see if 400 divides. At the bottom, this is what the Java code would look like. We would say y mod 4 equals 0 and y mod 100 not equal 0, or y mod 400 equals 0. Now this is logically correct. It's not as readable as I would like. The previous code, which is repeated below with slight modification, is evaluated in this way. We would start with y mod 4. The mod has the highest precedence, and it's the left-hand side of the logical and operator. Because of short circuit evaluation, we will evaluate the left-hand side first. We will do y mod 4, then we will compare that result to 0. Let's assume it's true. We're taking the year 1900 into account here. So that would be true. Because the left-hand side is true, this is an AND operator, we must evaluate the right-hand side. We now look at the rest of this expression and we determine that the mod is the highest precedence. So we do y mod 100. 19 mod 100 is going to have a return value of 0. So we're going to say 0 not equal 0. That's clearly false. So true and false is going to be false. The left-hand side is false. Notice I put the left-hand side here in parentheses, so it's obvious that this entire expression is one piece that has to be evaluated. The right-hand side of the logical OR is the other part that gets evaluated. Because the year 1900 makes the left-hand side false, short circuit evaluation for the logical OR operator says we must go ahead and evaluate the right-hand side, because if it's true, the expression is true. If it's false, the expression is false, because the left-hand side is false. We then would test 1900 mod 400. The mod goes first. 19 mod 400 returns something other than 0. We compare it to 0 and we get a false. So we get false or false, result false. The year 1900 is not a leap year. Let's try the year 2000. The OR operator has the left-hand side and the right-hand side. The left-hand side is in parentheses, so that is evaluated first. In that, we start at the left and go to the right. Y mod 4 is evaluated. 2000 mod 4 has a 0 remainder, so we would have left side of the and true. Because the left-hand side is true, the overall condition could be true. We must evaluate the right-hand side to see. We now do Y mod 100. 2000 mod 100 returns a remainder of 0. 0 not equal 0 is false. So we have inside the parentheses true and false. Overall result, false. Left-hand side of the OR operator, false. Because it's short circuit evaluation, we cannot determine the overall result of an OR just from the left-hand side when the left-hand side is false. We then must go to the right-hand side. Y mod 400 has a remainder of 0. 0 equals 0 is true. So the OR operator has left-hand side false, right-hand side true, overall expression true. The condition is true. Therefore, 2000 is a leap year.